This one is C6H10O4. It has two double bond equivalents. We have a 4H here and a 6H. Now we can be pretty sure that the 4H is going to be two CH2s. Further, we can see that they're under the same peak, so we know that these two CH2 groups are going to be related by symmetry. We also have a 6H over here, and generally speaking we know that a 6H could be either 3 CH2s or 2 CH3s, but the thing that we can say is when it's 1, 2 or 3 peaks under the 6H, we're generally looking at 2 CH3s, and when there's 4 peaks we're generally looking at 3 CH2s. This is all demanded by symmetry. If you'd like, you can stop the video and read about my discussion here. The 6H then is going to be 2 CH3 groups, and we are left with 2 Cs, 4 Os and 2 double bond equivalents. That would probably suggest that we have 2 C double bond O groups, and that leaves us with 2 oxygens. We don't have hydrogens on them, so we're looking at these groupings here. Putting it together, here's what we know. The CH3 groups have 3 peaks, and those peaks indicate that the CH3 is next to a CH2. Now further, we know that the two CH3s are equivalent because they're under the same peaks. So the CH3 over here must be adjacent to the CH2 as well. Now this is also given credence by the 4H, which is 2 CH2 groupings, because those have 4 peaks, which indicate that the CH2 must be adjacent to CH3, something with 3 hydrogens on it, and that's the case in both of these. The C double bond O's and the O's then need to be placed here. I'll move this over a bit. And we have to decide on the ordering. So really the two possibilities we can deal with here would be this one or possibly this one. And that's it. We can have the two C double bond O's together here, the O here, the O here. One thing we can't do is something like this. Now the reason for that is because then the CH2 here and the CH2 here would not be equivalent. This CH2 would be connected to an oxygen, and this one would be connected to a C double bond O. There's no way that those two CH2 groups could be the same. So these are the only two possibilities, having two C double bond O's in the middle or having the two O's in the middle. Now the reason that I would go for having the two C double bond O's here and here have to do with the location of the 4H. CH2s directly connected to C double bond O's tend to be in the 2 to 2.5 range, whereas CH2s connected to oxygens will be in the 4 ppm range. So the 4H here is between 2 and 2.5, and that's going to tell me that the CH2s are connected to C double bond O's, and this should be my correct structure.